Okay, everybody, so this will be the first video in a series of probably 3 videos to cover what power series are. And I think this will be complicated, just to be honest with you, at the front end. There's lots of fine print about power series, lots of details. And they may be hard to understand on their own, okay? But you'll have to watch the videos, but they're videos. You can pause them and think about what you're seeing. You can watch them again and give it more time to sink in. It's not like we're in class and you're just hearing this one time. I hope you take advantage of the videos, but I'll have to leave that up to you. And also, you're just going to have to ask questions. If you don't understand what this is about, once you see the video and think about it, then you'll just have to ask. And there's nothing wrong with asking if you need to. So, what is a power series? I thought I would just give you some examples. This is a power series right here. Okay. In each case, the x is a variable. It's something that is undetermined at the moment. And here's another power series. Okay. And what we notice about these first two examples is that all the terms of a power series are some constant times x to a power. All right, that's what power series are. Okay, so both of these have that in common, and maybe it's no big deal in either case what they are. All right, so that's what a power series is. Now, next question. So a power series is a series, and a series might converge or diverge. Okay, so if here are my first two examples of what power series are, these are just examples, all right? My question to follow that up with is, will a power series converge or diverge? My answer is it depends on what x is. The x is a variable in these series. And, how are you going to add this up if you don't know what the x is? How can you tell me what 1 plus 2x plus 4x squared plus if you don't know what the x is? So whether that series converges or diverges depends on what the x is. Maybe for some values of x it will converge, and for others it won't. Same thing with this. For some values of x, maybe it will converge, and for others it won't. All right? So a power series might converge sometimes, but it totally depends on what the x is. So let's see an example of that. Let's use this one that I already mentioned up here. Okay? Find the values of x that cause this power series to converge. All right. So, okay, let's do this. I'm going to go ahead and write it out because I think it can't hurt to do that. All right, so this power series is 1 plus 2x plus 4x squared, right? Plus 8x to the third power. And what I notice about this particular power series is that it's geometric. Okay? It has a first term of 1, and it has r to be 2x. It's true that the first term is 1, and if you take 2x times any term, you get the next term. All right? Okay, so that's true about this one. Now, I'm not saying that every power series is also a geometric series, just that this particular power series happens to be a geometric series. Okay? Now, in that case, if it's geometric, then I know conditions on convergence, right? A geometric series in general will converge if r is between -1 and 1, if the common ratio is between -1 and 1. For this problem, that equates to 2x being between -1 and 1. And ultimately, it means that this power series will converge if x is between -1/2 and +1/2. Okay? So those are the values of x that cause that series to converge. So if you took, if you let x be 0.1 and you put it in there, you get a number, and then you'd run the series out, you'd get a bunch of numbers to add together, and that series would converge. If you took x to be 5, well, 5's too big. 5's not in there. You put it in there, you get a series that doesn't converge. Okay? So those are the x's that cause this series to converge. Anything else won't. Now, this is called the interval of convergence. All right, which is a word or a phrase that we'll get very used to. What's the interval of convergence of a power series? Those are just the x's that lead the power series to converge. The interval of convergence is -1/2 to 1/2. The radius of convergence is a different concept. If you think about where's the middle of this interval? It's at 0. Then the radius of convergence is how far to the edges. So the radius of convergence for that interval is 1/2. All right, so that's 3 concepts. 1, what are the x's that cause a power series to converge? In the case it's geometric, we can do that right now, and I can tell you this, okay? Second thing, what the interval of convergence of a power series is. All right. Third thing, what the radius of convergence of a power series is. Okay. So at this point now, I'm using a geometric series just to get things going, just because it's something that's familiar to us already. So it will bridge the gap between something we know a little bit about already and then something that we probably don't know anything about. All right. Now, I'll need to give you the definition. It's just the way it is with math, is sometimes we have to talk about definitions. A power series we'll say centered at 0. And if you had a textbook or somebody else was telling you about this, they may say that a power series can be centered at numbers other than 0. But in my class, I'm just going to talk about power series centered at 0. Power series centered at 0 is an infinite series of this form. And where, like I said before, every term is a constant times x to a power, right? Yes, constant times x to a power, another constant times x to a power, another constant times x to a power. Every term is like that. Here's just that in series notation. Every power series has a radius and an interval of convergence. The 3 possibilities are that the radius of convergence is 0, or the radius is some positive number, or that the radius is infinity. All right? I think it will probably take some examples to see that, but I've given you one example already, that this power series has that interval and radius of convergence. Okay? All right, so some definition with some examples to go along with it. That's what we have at this point. Let me give you some more examples. So this power series right here that we have already talked about, we just talked about that one, has an interval of convergence like so. And sometimes we write the interval of convergence with actual interval notation. So instead of saying -1/2 less than x less than 1/2, we'll say in interval notation -1/2 to 1/2. The radius of convergence is 1/2. The middle of that interval is 0. That's how far it is to either edge, left or right. Here's another power series, okay? Interval of convergence for this one happens to be all numbers, meaning -infinity less than x to infinity in interval form, -infinity to infinity. This power series converges no matter what you let the x be. You can take any number you want and put it in for x in this series and start adding it all together, and you'd find out that it converged no matter what, okay? The interval is -infinity to infinity. The radius is infinity, okay? This power series only converges if x is 0. Any other number you put in, and then it doesn't converge, all right? Because like 0 is the only number it converges for, if you did put 0 for x, it would wipe out all the terms and it would converge to 1 because that would be the only thing left. All right, nonetheless, that's the only number that this power series converges for. All right, its interval is just 0 and its radius is 0. Okay, and then one last one. All right, what about this right here? Okay, that looks complicated, but I wrote it out for you. There it is. It's an alternating series that's also a power series. Every term is a constant times x to a power. This is 1/2 times x squared, 1/3 times x to the third power. It still fits my definition. All right. The interval of convergence for this one happens to be -1 to 1, including the 1. Okay. A power series might converge at the endpoints of the interval of convergence. All right. The radius is still 1. All right, so if the interval of convergence was -1 to 1 and it didn't happen to converge at the endpoint, we would still say that the radius was 1. All right. Okay, but nonetheless, this power series has an interval and a radius of convergence, just like all the others. All right, maybe they converge at the endpoints, maybe they don't. We have to probably determine that on a case-by-case basis. Now, at this point, you might be wondering, well, how do you know that? How do I figure out the interval of convergence? And is that something I'm going to have to know? And so on. Well, for that, I can only tell you this. We will learn how to find the interval of convergence in the next video. All right? Okay. Not right now. In the next video. For now, I'm just giving some examples so you know what the terms mean. All right. Okay. So let's see. Let's do. How about this? I told you I'm giving you examples so you know what it means. We should probably talk about what it means a little bit. Like, what does it mean when I say this series converges for those x's? That's the interval of convergence. Well, it's like the short answer is take an x in there, pick a number. Put it in here, and here, and here, and here, and you'll find you get a series that converges. That's the short answer to what it means. It turns out if you put 1 in, you get a series that converges. If you put -1 in, it doesn't converge, right? Those are the only numbers that it converges for. So let's elaborate on that with a few additional questions, okay? So when I say, like, this series converges, like, what does it converge to? Well, I'm using this same example just to establish some things. One, this is geometric. Okay? That r was 2x and the first term was 1. Okay? So this series will converge to whatever a geometric series like that converges to. Okay? So that means this. It means this series right here, which is what? 1 plus 2x plus 4x squared plus 8x to the third power. All right, and that goes on and on. That series will converge, because it's geometric, to a1 over 1 minus r. Okay? So what does that series converge to? It converges to this. And that gives a statement that this power series is equivalent to that function. What do you think that means? That means when you put values of x in within the interval of convergence, this is equal to that. All right? So what was the interval of convergence? We worked this out earlier. It was -1/2 to 1/2. All right, so there's my statement. Now, do you understand what that means? When I say you can take an x in here, and this series will be equivalent. It'll give you the same number as whatever that function does. Let's illustrate that. What does this mean? When I say what does this mean, this I'm talking about is that, all right? What does that mean? Okay, well, it means that this equals that for all values of x in that interval. So let's illustrate it. If you want to understand math, like sometimes it might just help to try to start seeing some numbers. So I took, just for the sake of illustration, I took an x within that interval of convergence. I put it in this series right here. I didn't write the whole thing because I can't, all right? This whole series is infinite. How can I write down all of it? I can't, all right? But I wrote it up to the term 16x to the fourth power, all right? So I put that in, I put that x in, you get 1 plus, there it all is. And then I put that same x into this function, 1 over 1 minus 2 times 0.1. And I calculated both of them. You know, I did all this with my calculator. I got 1.2496. I did that. I got 1.25. They're real close. Why aren't they equal? They'll be equal if this series is infinite. If I truncate the series at some point, I'm going to lose some of my numbers. It will only be approximate. But that's what it means, right? With numbers, I can illustrate what it means. So if you have trouble understanding this right here, like you say you read that, it just doesn't sink in. Well, like calculations will probably sink in. You probably will understand that. All right? Yeah, do the math if you need to. Try with numbers if it helps you understand it. Right? So that I'll show you this kind of thing a lot. When you watch other videos, even though I go into more complicated things about this, I'll still illustrate with numbers what I'm trying to say, just because it might help you maintain your focus, all right? So this won't be the last time you see that. I'll keep using it because I think it could be good for you. But it gives you a way to understand that right there. And that's where I need you to be. I need you to understand the meaning of a statement like that.